So I think we should get started. Hello
Okay.
everyone. My name is Malik Arslan Nisar and I am one of the TAs for this course, Numerical Linear Algebra. So this is the third problem solving session. Yes. So we shall begin and I request you guys to solve along with me some of the problems. So is my screen visible and am I audible to you?
Yes, yes, yes.
Okay. Yeah. So anyone who wants to summarize what you did in this week? Like what all topics were covered? Anyone? Okay, so I think most of the topics during this week was revolved around eigenvalues, eigenvectors, and eigenvalues, eigenvectors, and I think Cayley-Hamilton theorem, null space,
And
etc.
orthogonal subspaces also.
Yeah. So, did you guys try the assignment as well?
Yes.
Okay. So, let's start with simpler questions, then we will move to more complex problems. Given an 2 cross 2 matrix, A equal to 7, A minus 3, and B.
Your screen is now not audible and it's visible.
Okay, my screen is not visible.
Yeah.
Wait a second. Yeah, so now is it visible?
Yes, yes, yes.
Okay, okay. Wait a second. Some people are joining. Let me allow them. Yeah. So, given this matrix and its eigenvalues, lambda 1 equal to 4 plus root 3 and lambda 2 equal to 4 minus root 3, then sum of wait a second. Some people are still joining. Guys, please try to join on time because like we have to complete this session up to 9 and then we don't get enough time to discuss the problems. Uh, so yeah, is my screen visible?
No, it's not.
I don't know why this is happening today. Um, Now is it visible? Yeah.
Yes,
Now is
yes,
it
yes.
visible? Yeah.
Yes.
And it has the values given as this. Now we have to find the wait a second. Then find values of A and B. So using the properties of eigenvalues, you have to solve this question. I'll give you a minute, you can try it on your own, then we'll discuss. So any clue what properties will we use or how we will approach this question?
This lambda I minus determinant of lambda I minus a equal to 0. From that we can equate to the eigenvalues.
Okay, you can try to calculate. Give me the values of A and B. Anyone else? So see here, we will discuss the solution. A equal to 1 and B equal to 2. I think A should be 2 and B should be 1. So maybe you can check here. Okay. So here we have the two properties which we can use. First of all, we know that sum of eigenvalues is equal to what? Trace of the matrix, right? Yeah. So sum of eigenvalues here we can do as 4 plus root 3 plus 4 minus root 3 is equal to trace of the matrix, which is equal to 7 plus b. And from here we can easily calculate b is equal to 1. And the next property is about the product of eigenvalues. What is the product of eigenvalues equal to? Anyone?
uh, Determinant of the matrix.
Yeah, it is equal to the determinant of the matrix. So from here, we can simply multiply 4 plus root 3 into 4 minus root 3, which is equal to determinant of the matrix, which is 7b plus 3a. So 7b plus 3a is equal to this. It will be a square minus b square, which is equal to 16 minus 3 equals to 7. Let's put the value of b and 3a. So it will be 16 minus 3 is 13 minus 7 is equal to 3a. It implies a is equal to 6 by 3, which is equal to 2. So it was very simple. You can note down the solution. Then we'll move to the next question. Okay. Should we move ahead?
Okay.
Okay. So, question number 2 is that we have a matrix A given, which is equal to 1, 0, 0, 2, 1, 0, 3, 2, 1. Now, there are few statements and we have to check them regarding the eigenvectors of the matrix. So, which of the following holds for eigenvectors of A. So there are few statements. I think first we should calculate eigenvectors, then I will move to the statement part, because obviously we have to solve for the eigenvectors first. So I hope you by now you know how to solve like how to calculate the eigenvectors. So take a minute and try to do it on your own, then we'll discuss. Is there anyone who does not know how to solve or how to calculate eigenvectors? You can raise your hand. Are you people solving? At least respond with yes or no or anything.
Yes, yes.
So that I know that should I
Solving,
stop?
solving.
Huh.
It's 3 1 1 1.
Huh? It's 1 1. Okay, that was very obvious also. The eigenvalues corresponding to a lower triangular matrix are its diagonal elements. Okay, you all should be knowing it. You can note it down as well, that for a lower triangular matrix, the diagonal elements are the eigenvalues. So lambda 1 is equal to 1, lambda 2 is equal to 1, lambda 3 is equal to 1. Now, what you will do, you have to find the corresponding eigenvector. So, tell me what vector you are getting. How will you find the eigenvector?
Substitute each eigenvalue in lambda I minus a
Huh.
into x1, x2, x3 equal to 0. That will
Yeah.
do. And try to solve for
Yeah.
x1, x2, x3.
Yeah, okay. So, you should solve along with me. I'll also try to do it. So, to find lambda, to find eigenvector corresponding to lambda equal to 1, what we will do is a minus lambda I, we will multiply it with a vector like the eigenvector which you are calculating and equate it to 0. From this equation, we have a equal to 1, we have a equal to 1 0 0, 2 1 0, 3 2 1, minus 1 into identity matrix, and we multiply it with the eigenvector v1 v2 v3 and equate it to 0. So from here, this is coming out to be 0 0 0, 2 0 0, 3, it will be 3, it will be 2, and it will be 0 into so the first equation which we will get from this is 0 times v1 plus 0 v2 plus 0 v3 equal to 0. So this equation says that v1, v2, v3 can have any values. So we'll move to next. From here to v2 is equal to 0, which implies that v2 is 0. Correct? And
2v1 or 2v2?
V1.
oh, sorry, 2v1.
2v1.
2v1, it is going to be 2v1, sorry. So 2v1 equal to 0 it corresponds to V1 equal to 0. And then the third equation is 3V1 plus 2V2 is equal to 0. Now V1 is already 0, it implies V2 is equal to 0. So from equation 2 and 3, we get the values of V1 and V2. So yeah, V1 and V2. So V3 we can choose according to our own choice. Like we can say V1 is a combination of V1, V2 and V3, which is equal to 0, 0, V3. Taking V3 as common, we get the eigenvector as 0, 0, 1. And V3 we can choose according to us, we can put its value as 2, as 3 or as 4, anything, whatever we like. Now going on to the statement part, which I was telling that in this question, there is written that all eigenvectors of A are scalar multiples of, then the options are all eigenvectors are scalar multiples of. The options you have been given is 1, 1, 1. The next option is 0, 0, 1. Third option is 1, 0, 0. And fourth option is 3, 2, 1. So which of these is correct?
B.
Second one. So how many of you got it right? How many of you did it correctly? Okay, fine. Anyone else? What about others? Okay, Kavita, you have also done it. So, should I move ahead or other people need time to copy it? What about others apart from Kavita and Gifty? Have you guys noted it down? Okay. So we should move to next question. I don't know, there is some issue with my iPad today. Is my screen gone again?
Yes. Yes. Yes.
Okay, sorry, bear with me guys. I don't know what issue is there. Okay. So, let's move to next question. Okay, this one is a simple question. It was asked in GATE 2019. So, let's do this. Consider the matrix A whose eigen values lambda 1 and lambda 2 are x1 and x2 respectively. The value of x1 the value of the value of transpose of x1 into x2 is, so matrix A is given as 50, 70, 70 and 80, and x1 is given as 70 and lambda 1 minus 50, and x2 is given as lambda 2 minus 80 and 70. So we are given a matrix A and its corresponding eigenvalues. The eigenvalues are lambda 1 and lambda 2, not x1 and x2. No, sorry, the x1 and x2 are the eigenvalues of this. Wait a second, I think there is some misprint in the question. Sorry. Okay, this is not eigenvalues, it should be eigenvectors. Yeah. Whose eigenvectors corresponding to, yeah. So the lambda 1 and lambda 2 are given as the eigenvectors of the matrix A and the corresponding eigenvectors are x1 and x2. Correct. Now the value of transpose of x1 into x2 has to be finded. So try to solve it on your own. Then we will discuss. Anyone got the answer? So basically we have to find x1 transpose into x2, which is equal to what? 70 lambda minus 50. Sorry, it's we have to take the transpose. So x1 transpose will be 70 lambda 1 minus 50.
Answer 0.
Yeah, 0 is the right answer. Anyone else got it? So how did you do it, Kavita? In the same procedure?
Yes, ma'am. Yes, ma'am.
Okay.
And I use it after multiplying with lambda 1 minus 50 and lambda 2 minus 80. I just use the sum of the eigenvalues is equal to trace of the matrix. That
Okay.
idea only I used.
Cool. Oh. So from here, you can do it in that way also. Others can look at the screen. It is going to be 17 to lambda 2 minus 80 plus lambda 1 minus 50 into 70, which will be equal to 70 into lambda 2 minus 5600 plus 70 lambda 1 minus 3500. Yeah, no, it will be plus, I guess. No, minus. Okay. It is going out to be 70 into lambda 1 plus lambda 2 minus 130. Am I doing it right? You guys can tell me if there is any mistake. So here, yeah, lambda 1 plus lambda 2, we know that this is the sum of the eigenvalues and it is equal to what? Trace of the matrix. So since the matrix is given, we can simply write 50 plus 80 instead of lambda 1 plus lambda 2, right? So we will do it like 70 into 50 plus 80 minus 130 and it is coming out to be 0. So how many of you followed the same procedure? There was alternative way that you could first find out simply the eigenvalues of the matrix A, then put it in x1 and x2, and after that then you could perform the same. But now I will tell you a short trick of this question. If you look at the matrix A, it is a symmetric matrix, and right, it is a symmetric matrix. Here you have 70 70. So the transpose will be same as the matrix. And there is this important property of symmetric matrices, that the eigenvectors of symmetric matrices are orthogonal. They are orthogonal to each other. So we, from that itself, we can find that x1 transpose into x2 is going out to be 0, because for orthogonal matrices, if we take the dot product, that comes out to be 0. So without solving any of this, if you could just look at A and say, yeah, it is a symmetric matrix, the eigenvectors are going to be orthogonal, so the dot product will be 0, x1 transpose x2 will be 0, right? It would save you a lot of time. So that's the thing with these exams, competitive exams, they give you these questions. So have you noted it down,
Yes.
everyone? Like others who are not able to solve? Okay, so should we move ahead? For next question. Okay. So next question will is given as A is equal to 5, 3, 1, 3. I think my screen is again gone. We have been given a matrix A, which is equal to, which is a 2 cross 2 matrix. So you have to find one of the normalized vectors, one of the normalized eigenvectors, normalized eigenvectors. So do you people know what a normalized eigenvector is? Anyone?
The eigenvalue which is having the sum square as 1.
Yeah. So normalized means nothing. You have the eigenvector, you have to divide it by its magnitude so that you get a unit vector. And that is known as a normalized vector, normalized eigenvector. So please try to do it on your own. Firstly, you have to find eigenvector and then you have to normalize it. I want you to solve it on your own. So I am giving you 2 to 3 minutes and tell me what you are getting. I will give you options also. So everyone please solve it and put your answers in chat box. And I want each one of you to solve it. Because if you have joined this session, it means you want to like practice some questions. So you should at least give it a try.
The screen not visible.
Oh, screen is not visible again. I don't know what is happening to this. You people try to note down the question first because I don't know what is happening today. So check this. Now is it visible? Yeah, please note down the question and then solve on your own end because maybe my screen will go blank again. How many of you are registered for the exam of this course? Kavita and Gifty. What about others? Option B. Okay, Kavita. Option
Ma'am, actually, my semester exam just ended, so I have not decided yet.
regarding what? Okay, regarding like registering for exam. Sachin, I didn't get what you were telling. Can you repeat it? Okay, whatever. Anyone else who got it? Kavita, you got option um, B. So, how did you solve
Yes.
it?
First, find the eigenvalues.
Mm-hmm.
Eigenvalues 2 and 6. For
Yeah.
lambda equal to 2, my eigenvector is 1 and minus 1. Then
Okay.
I normalized it.
Hmm. Okay. Hmm. Yeah, that is the correct way to do it. There is also another way, but first I will show you this way only, then we'll discuss it that way. So, first of all, you have to find the eigenvectors, which you all should be knowing that how to find it. First, we will get the eigenvalues from this equation. So, in order to complete it, help me with this. This will be 5 minus lambda. This will be 3. This will be 1. This will be 3 minus lambda. And it is going to be 5 minus lambda into 3 minus lambda minus 3 equal to 0. From here it will be 15 minus 3 lambda minus 5 lambda minus 8 lambda, and then plus lambda square minus 3 equal to 0. Then lambda square minus 8 lambda plus 12 equal to 0. From here it will be lambda into lambda minus 6 minus 2 into lambda minus 6 equal to 0, which gives us lambda equal to 2 and 6. Now first we will find eigenvector corresponding to lambda equal to say 2. Now corresponding to 2, what we will do, a minus 2i into say v1 equal to 0. Then here, what is a minus 2i? Quickly, I want,
3, 3, 1,
yeah,
1.
3 3 1 1 equal into v1, say the components are alpha 1 alpha 2 equal to 0. It is going to be 3 alpha 1 plus 3 alpha 2 equal to 0. From here alpha 1 plus alpha 2 is equal to 0. Second equation will also give you the same, which gives alpha 1 is equal to minus alpha 2. So now here let the vector was v1 equal to alpha 1, and now what is alpha 2? Alpha 2 is minus of alpha 1. So taking alpha 1 is common, we get 1 and minus 1, and we can assume alpha 1 equal to 2. Sorry, 1. We can put a 2 also, but 1 will make it simpler. So put alpha 1 equal to 1. It is going to give us 1 and minus 1. Now, this is the eigenvector, but it's not normalized yet. So for normalizing it, what we will do? This is vector v1. So u1 will be equal to what? The normalized vector will be equal to what? The vector v1, which we already got, divided by its magnitude. So what is the magnitude here? Under root of 1 square and minus 1 square. So 1 square plus minus 1 square ka under root into the eigenvector, which is 1 and minus 1. So it is going out to be 1 upon root 2 and minus 1 upon root 2. So this is the second option, right? I think, yeah, it was the second option. So how many of you checked for lambda equal to 6? Kavita, did you do for lambda equal to 6?
Yes, ma'am.
So what was the normalized vector for that?
Yes.
Huh?
First, the eigenvector
Huh.
is from eigen. The eigenvector is 3, 1.
Yeah.
Then normalized is 3 by root 10, 1 by root 10.
Yeah, correct. So that is not given in the option. That is why there is only the second option is correct. Did you guys understand it? Others? Do you want to note it down? Or at least respond like you need time to note it down, or you were like writing along with me? Okay, you need time for noting down. Okay. Tell me when I have to scroll, then. Okay, done. Noted this portion also. Yeah. About another way, like how we can do it, that yeah, we can simply like multiply if it is an MCQ based question, and like this way also it is easy, but say it is a bigger matrix, 3 cross 3 matrix, then in that case this method may be lengthy, but what you can do is you can simply multiply the matrix A with each of these normalized, like with each of the options. When you multiply matrix A with this option, if you are getting a scalar multiple, that means it is a normalized eigenvector. If you are not getting a scalar multiple, then it's not going to be a normalized eigenvector. Like I did it for all 4 options. In option, I will not do it again. Or do you want me to do it again? Let me show you for part 1 and part 2. See, alternative solution. What we can do is, we have this matrix 5 1 5 3 1 3, and what we can do is, for we will multiply it with 1 by 2 and root 3 by 2, which is the first option, and it is coming out to be 5 plus 3 root 3 by 2 and 1 plus 3 root 3 by 2, right? So it is not a scalar multiple of this vector, so this is not a normalized vector. Then moving to the correct option, which was wait a second, I have to go back to question. Yeah, 1 by root 2 and minus 1 by root 2. So if I multiply this matrix with 1 by root 2 and minus 1 by root 2, so what we are getting here is, if you solve it, it is 2 by root 2 and minus 2 by root 2, which is what? 2 into 1 by root 2 and minus 1 by root 2. So this is nothing but just a scalar multiple of this. So from this way also you can find out what is the normalized eigenvector for them. And yeah, obviously you have to check that the value should be equal to 1. If you are taking the if you are taking the magnitude of the components, it should be 1, which in this case for all 4 options that is 1, but they were not normalized, because see here only it is coming out to be a scalar multiple of the original vector. In other options it's not coming out. Did you understand what I am trying to say here?
Yes, ma'am.
Okay. Sachin, can you unmute yourself? Because I have seen you for the first time in the class.
Yes, ma'am.
Okay. So, so have you copied this?
Yes.
Okay. So let us move to next question. Find the basis for the range space of the transformation given by the matrix A equal to 1 2 3 0 0 2 yeah. So we have a matrix given and we have to find a basis for its range space. Since we I think we have not discussed range space, but in week 1 lectures also range space etc was mentioned. So anyone wants to tell what a range space is? A range space basis? Anyone? Range space is nothing but which is spanned by the output, right? So for that, if we have to find the basis and you look at this matrix, you can visually get the answer. See, first and second column, they are linearly dependent, right? So either column 1 and column 2 are linearly dependent. So only two of them you can take as independent. Either you can take C1 and C3 as independent, or you can take C2 and C3 as independent. One of them is going to be dependent. Like that will depend on the, these are nothing but three vectors, as I have already told you. You can take it as the vector. And two of them are independent and one is going to be dependent. Whether you can choose C1 and C3 as independent, or you can choose C2 and C3 as independent, because C1 and C2 have a relation. You just multiply C1 with 2 and you get the second vector. So from here, what you can say is that any of these two is going to be the basis for the range space. Like you can choose 1 0 0 3 2 minus 1, or you can choose 2 0 0 3 2 minus 1. So this is simply going to be the basis for the range space. These are the two possible answers, because the question from where I took it, it was an MCQ type question, and it had 4 options and only this one was given as the correct option. This was not present there, but these are the two possible answers. Like this is also correct and this is also correct. So the range of A is from these two only. Understood this one?
Yes.
Note it down. Okay, so another simple question based on this. Did you note it down?
Yes.
Yeah. I'll give you a matrix A equal to 0, 0, 1, 1, 1, 0, 0, 1, 1, 1, 0, 0, 0, 1, 1, 0. So for this matrix A, can you tell what is the basis for the range space? By visual inspection, what you just understood. Kavita, Gifty, any one of you? You just have to find which are independent and which are dependent.
All are independent, it seems.
Sorry?
All are independent, isn't it?
All are independent. And how did you conclude that all are independent? Because this is not the RREF form. You can see ones and zeros, but it's not like it is an RREF form, right? They may look like all are independent, but they all are not independent. I want you to look closely.
Actually, it is a dependent.
Yeah, which one is dependent?
I just check it out by determinant is 0, so I said it is a dependent.
Yeah, it is
But I am
dependent.
not
But
getting the relation.
yeah, for range space, you need to find out that, right? You have to say which one is independent, then only you can say, if the question comes that find the range space of this. So for that, saying that all are not independent is not enough. You have to find which three will constitute the like I will tell you, one is dependent, the rest three are independent. See, look closely. If you look at column 1 and add it to column 2, then from it subtract this column, you are going to get this column. See, 0 0 1 1 1 1 0 0. Adding these three will give adding these two will give you a vector 1 1 1 1. Subtracting from it 1 and 0, you will get this, right? So here
Yes.
C1 plus C3 minus C2 is going to be C4. So we have only one equation. One equation, four unknowns means one is independent and other, sorry, like one you can choose. So one is going to be, from this equation you can find out only one. So that is the dependent one and rest three are independent. Rest you can choose. Three you can choose and you will get the value of the fourth one. So you can choose first, like you can say the last column is dependent, so only the first three columns are independent. So you can choose like 0 0 1 1 1 0 0 1 and 1 1 0 0 gives the range space of A. Got it?
Yes.
Yeah. So copy it down, then we will move further. Okay. So did you learn during the week how to find null space of a vector? In assignment 3, are there any questions based on null space? Because I went through the topics of the week 3, so null space was there. Anyone?
In assignment questions is not there, but the topic is there.
Yeah, topic was there.
Like column space, row space, and null space.
Yeah. So null space is one of the important topics, like in linear algebra. You should like know how to find null space. Because as we move towards the end of the session, you will realize like why is it important and how to like do it. So can you try this on your own, how to find the null space? Any approach? Because I just don't want to solve it like, I want you guys to solve it first. Anyone has any clue? How do you
Dimension minus rank. Can we get
huh?
dimension of the matrix minus rank?
No, that is nullity.
Nullity. Okay.
That's not null space.
Okay.
Nullity tells you about the like sort of dimension of the null space. That is what nullity is. But that is not null space. So I will tell you one thing. See, first there is this thing that for any matrix A and its row reduced echelon form, the null space remains the same. You should note this point down. The null space of A and its row reduced echelon form RREF, which we denote as A tilde, are same. There are so many properties which change as we take the RREF, like determinant, etc. But null space remains same. So first I want you people to calculate its RREF. Please do it quickly. Are you guys solving or not? Because my screen is not there anymore. Take a minute and tell me what you are getting as the null space. So, anyone got the RREF? Ronak, you tell me. Are you solving?
Yes, ma'am.
So, did you arrive at the RREF?
No, ma'am.
Which step you are on?
R2 is equal to R2 minus 7 R1.
Okay, that is the first one. Then,
R3 is equal to R3 minus 5 R1.
yeah, correct. Then you got like first after first transformation. The second one you did.
No, ma'am.
So, how will you do the second one? You will make the second row's second element, which is 13, as you have to make it 1, so divided by 13, right? That is how you proceed now.
Yes, ma'am.
Yeah. Anyone who has arrived at the RREF? Kavita or Gifty? Pratiti, you are for the first time I've seen you in the class. So, are you solving? Okay. So, you guys can continue what you're doing. Let me, in meanwhile, I will also tell you. First, we will do R2 is equal to 7 R1 minus R2, or you can do the reverse like Ronak said, but I'm going to do it this way only. 5r1 minus r3. This will give you something like 100, 213, 8, 3, 19, 14, 4, 25, 18. The second transformation is r2 by 13, which is going to be like r2 is r2 by 13, which is going to be 100, 218, 3, 19 by 13, 14 by 13, 4, 25 by 13 and 18. Sorry, it's not 13 here.
It's 8.
Huh?
8, no?
No, it's 18. It's coming out to be 18.
18. Yeah.
Huh. So, and what will be the third step? Now we have to make these two zeros. So R3 will be what? R3 minus 8R2 and R1 will be R1 minus 2R2. So help me in completing this. What is this going to be? Fast.
1, 1, 2, 3, 4.
1. Okay, wait a second. No, this one is not going to be.
1, 0, 0, 2, 1, 0.
Yeah, it is going to be 1, 0. What will this one be?
It's column wise now.
Okay, you are telling me column wise. Okay, 1, 0, 0,
2,
0,
1,
1, 0.
0.
Then
3, 19 by 3.
3. No, it's not going to be 3 because see, we are doing a transformation here, na R1 mein. So R1 will change. So it is going to be 1 by 13. Here it will be 19 by 13 and 30 by 13. This will be 2 by 13, 25 by 13 and 34 by 13. And whenever you are performing row transformation, like tell it row wise only. Then what is there? Now you have to make this one. So simply R3 by 30. This one you have to make a 1, hai na? This 30 by 13. So R3 you will divide by 13 by 13, which is like this. And it is coming out to be 101 by 13, 2 by 13, 01, 19 by 13, 25 by 13, then 001, 34 by 13. Yeah. Now what is the next step? These two you will have to make 0, and for that you will do R1 minus 1 by 13 R3 and R2 minus 19 by 13 R3. So help me complete this one. What is it going to be? I am not writing it. You will tell me what it is going to be. What is the first row? Take your calculator and perform it right now also. You can do it. Maybe Ronak or Simchan, any one of you, or Pratiti. Yeah. So this one is going to be 1, 0, 0, 1 by 15. The next one is going to be 0, 1, 0, 4 by 15. And the third one is going to be 0, 0, 1 and 17 by 15. See, clearly you can see these three are the independent column vectors, right? Now, This is the RREF. You can call it as A tilde or RREF. So are we on the same page? Everyone has done till this step? Then I'll move forward. I want you to respond. It can be a no also. Everyone has arrived at this step, the RREF. What about others?
I have a doubt. The first row, the first element is 1 only, no? Then we want to change, transform it. Can we keep as such? 1, 2, 3, 4.
We can. We did not change it. It was 1, 2, 3, 4 only. But
But I'm getting the same. First I kept 1, 2, 3, 4, then 0, 1.
yeah, but see, you can keep 1, 2, 3, 4 as it is, but then you have to make
Again,
this
this
2
0, 1,
zero.
19 by 13, 25 by 13. Third row 0, 0, 1, 17 by 15. Like that I got.
See, row transformations can be different, but ultimately you should be getting this RREF
Yeah.
because RREF is, you got
Yeah.
the same RREF, na?
Last 2 rows I get same. First I kept as such. First row it is 1, 2, 3, 4.
No, for getting the RREF, you have to change them also. You can only keep the leading entry as 1. Others, you have to try to make 0. No. See, I arrived at this form. What I said in first lecture was that the leading entry should be 1
1.
and others should be 0.
Okay.
At least you have to try to make them 0. Here, see, what the approach is basically, we try to make it as a unity matrix. And here you can see like diagonal elements are 1, others you have to keep in the same column, you have to try to make them 0. That's why you did those. Otherwise, 1 you did not have to change.
Okay.
So this is going to be the final RREF. If everyone has got it, that is fine. If not, you can check it at your own end again. Okay, so you haven't covered this. Okay, Shinchan, like we are going to meet next week. So probably you will get 1 week for covering up the topics, important topics. Then it will be easy for you to understand. Because right now I cannot repeat everything. So that will take a lot of time. Now, look carefully here. As I already told you, our goal here is to find the null space. So the null space of A and A tilde, that is going to be same. What have I already told you about null space? Null space is nothing but it is a set of vectors, right? I have already mentioned it that it is a space, subspace or set of vectors over which the linear transformation or the matrix A operates and makes it 0, right? So it should satisfy this condition. Now here 1 0 0 0 1 0 0 0 1 1 by 15 4 by 15 17 by 15, and what is the x going to be? It is going to be the null space. So it will have component x1 x2 x3 and x4, right, and equated to 0. So from here what we will get is the first equation is going to be x1 plus x4 by 15 is equal to 0. Next is x2 plus 4 times x4 by 15 is equal to 0. Third is going to be x3 plus 17 by 15 x4 is equal to 0. You understood how we get this? Everyone?
Yes.
Nothing but just multiplying this row with this column, you get x1 plus x4 by 15 equal to 0. Now, and one more is x4, it is equal to what? Nothing but x4. Because there is no fourth row, so x4 will be x4. That is like easily understandable. In like here you can see that from the equation 1, 2 and 3, you can express x1, x2 and x3 in which form? In the form of x4, right? it is clearly understandable that x1 can be expressed as minus x4 by 15, x2 can be expressed as minus 4x1 minus 4x4 by 15, and x3 can also be expressed as minus 17 by 15 x4, right? And x4 is x4. So what was the null space? Tell me again. The null space was nothing but the x vector, which had x1, x2, x3, x4 entries, right? That was the null space. So x was the null space, which I can say null space x was nothing but x1, x2, x3 and x4. Here we can replace all of them with their we can replace them with the values of x4, like minus x4 by 15. We can write it as minus 4 times x4 by 15, minus 17 times x4 by 15, and the last one is going to be x4. Taking x4 common, what we get? Please repeat. It will be minus 1 by 15,
minus
minus
4 by
4 by
15,
15,
minus 17 by 15,
minus 17 by 15, and
1.
the fourth one will be 1. So this is the null space of the vector. Like x4 you can choose on your own, and you can say put put x4 equal to 1, and you will get this as the null space. Understood how you got this and the concept behind it?
Yes.
Okay, so tell me what the range space will be here. And what will be the rank? Like you can orally say it. What was the rank of this matrix?
Rank is 4.
Rank is 4. No, rank is not 4.
2.
3.
2. Rank is 2.
Rank is 2. No.
3.
Sorry.
Rank is 3 because 3 different variables.
Rank is going to be 3 here.
3.
Rank is 3. Range space dimension is 2.
No, range space will also be 3 because it will be the span of
3.
these 3 columns, which we got earlier. The column 1, column 2, column 3.
Uh,
Column
hmm.
4 will not be included, so range space will be a span of these 3.
Okay.
My screen is gone again, I think, right?
Yes.
I don't know what is happening today. I had to check it. So you all noted now?
Yeah.
Okay. So diagonalization you have studied during this week, right?
Yes.
Okay, since there is not much time left, I think 3 more questions we will be able to do. 2 on diagonalization and 1 simple question on Cayley-Hamilton theorem. Okay. So yeah. So we have this question: compute P inverse AP and then A to the power n if A is equal to 6 minus 5 2 minus 1 and P is equal to 5 2 1 and 1. This is the question, but for time being I want you guys to ignore the question and Focus on the solution. See, let us consider a matrix which was given in the question also, 6, -5, 2 and -1. This is a matrix which we have been given. I want you to find out its eigenvalues quickly. It is a 2 cross 2 matrix, won't take much time. So tell me the eigenvalues quickly. It will be 6 minus lambda minus 5, 2, -1 minus lambda का
Lambda
difference.
square,
Huh? What
lambda
is?
square minus 5 lambda plus 4.
Give me the values of lambda. That are the eigenvalues, no?
1 and 4.
1 and 4, right? So yeah, that is correct. It is going to be lambda square minus 5 lambda
5
plus 4
lambda
equal
plus
to
4.
0. So lambda minus, you can write it as lambda into lambda minus 4 and -1 into lambda minus 4 equal to 0. From here, lambda minus 1 into lambda minus 4 is equal to 0, and we get the values of lambda as 1 and 4. Correct? So these are the eigenvalues. So here we have two distinct eigenvalues. Now give me the eigenvectors corresponding to it. Tell me what are the eigenvectors corresponding to lambda equal to 1 and lambda equal to 4. Now everyone should be able to do it, because this is, I think, for the third or fourth time we are doing it in the session. And these are like really important things. You will be using them. That's why I want you to practice more and more. Everyone, tell me what are the eigenvectors.
One eigenvector is 1, 1.
Okay, yeah, correct.
Another one is 5 2.
Another one is 5 2. Yeah. Others have gotten it. Others, what about others? Are you guys on the same page? See, now lambda corresponding to 1 is nothing but how we find out the eigenvector. I will tell you again. So look clearly. We have the characteristic equation, or like we got here 6 minus lambda, then -5, then 2, then -1 minus lambda. So you have to do nothing, but you have to put the value of lambda in that matrix to find out the eigenvectors. So here what we had 6 minus lambda for just the understanding of everyone, and -1 minus lambda, right? It was something like this. Now putting the value of lambda equal to 1 here, what we get? 6 minus 1 is equal to 5. Then it will be -5. It will be 2 only, and here it will be -2, right? अब अगर इसका हमें आइगन वेक्टर फाइंड आउट करना है, देन the eigenvector is going to be something say equal to alpha 1 alpha 2, and we equate it to 0. That is the very basic definition हम लोग जो बोलते हैं eigenvector की. तो ऐसे हम eigenvector फाइंड आउट करते हैं. तो यहाँ से हमें मिलता है 5 alpha 1 minus 5 alpha 2 is equal to 0. और दूसरी इक्वेशन दैट इज अगेन रिडंडेंट, वो सेम ही आएगा. It will give you what? Alpha 1 is equal to alpha 2, right? एंड यहाँ पे यू कैन राइट, हाँ, अल्फा 1 इज इक्वल टू अल्फा 2. तो अल्फा 1 को बाहर निकालो और यहाँ पे आएगा 1 1. पुट अल्फा 1 इक्वल टू 1. कुछ भी ले सकते हो वैल्यू, लेकिन हम 1 लेते हैं. तो हमारा जो v1 आता है, जो पहला आइगन वेक्टर आता है, दैट इज 1 and 1. अंडरस्टूड? नाउ कॉरेस्पॉन्डिंग टू लैम्डा इक्वल टू 4, यू हैव टू डू इट अगेन. ठीक है, अगर अभी पहली बार आपसे नहीं हुआ, एटलीस्ट ट्राई हेयर. दिस टाइम इट शुड बी करेक्ट. तो ये होगा समथिंग लाइक दिस. इसको मान लीजिए v2 एंड यहाँ पे कह दीजिए इट इज β1 एंड β2. ठीक है, सो अगेन यू कैन सी दोनों इक्वेशंस बराबर हैं, तो यहाँ से हमें मिलेगा 2 बीटा 1 माइनस 5 बीटा 2 इज इक्वल टू 0। दूसरा भी सेम आएगा तो हम करेंगे नहीं, यहाँ से हमें पता चलता है बीटा 1 इज इक्वल टू वॉट 5/2 बीटा 2। सो बीटा 2 मतलब अगेन मैं आपको बता रही हूँ कि V2 हमारा क्या है यहाँ पे, इट इज नथिंग बट बीटा 1 एंड बीटा 2। सो पुटिंग द वैल्यूज व्हाट वी गेट, बीटा 1 की जगह 5/2 बीटा 1 और ये नहीं सॉरी इट इज बीटा 2। हाँ, यहाँ से वी कैन टेक बीटा 2 एज कॉमन and what we will get 5/2 and 1. Now what should I choose the value of beta 2? We can choose 1 also, we can choose 2 also, लेकिन I will choose क्या यहाँ पे I will choose it as 2 ताकि ये जो fraction है it should go away, it will make it more like appealing. Why would I want a fraction in this vector? So मैं beta 2 की value 2 लूँगी, put beta 2 is equal to 2 and what will be my eigenvector now? Now it will be 5 and 2. Got it?
Yes.
Now see clearly, let us define a matrix, ठीक है, matrix P called as modal matrix. Up to this point सबको समझ में आया? Everyone got till here? Understood till here?
Yes.
Everyone, I don't want answers from Kavita and Gifty only. Others should also respond. यहाँ तक सबको समझ में आया? Apart from those who are joining for the first time or okay. So Ronak, what about you?
Yes, ma'am.
Did you understand?
Yes, ma'am.
So now what we will do, we will define a matrix P which is nothing but the eigenvectors of the matrix A. See, we had a matrix and we found out its eigenvectors. They were both different, like दो distinct eigenvalues मिले हमें, उसके corresponding दो different या दो distinct eigenvectors मिले, V1 और V2. यही मिला ना हमें, which is equal to what? V1 was what? 1,1 and V2 was what? 5,2. तो इस मैट्रिक्स को हम बोलते हैं मॉडल मैट्रिक्स, ठीक है. Now can you find the inverse of this matrix quickly? 2x2 का मैट्रिक्स इनवर्स फाइंड करना बहुत इजी है ना? You all are comfortable with Hindi?
Yes, ma'am.
Gifty, Kavita,
No, no.
Okay, you're not that comfortable. Like
Yeah.
थोड़ा बहुत समझ आता है?
I'm basically from Tamil Nadu, madam. I don't know
Okay,
much
so you
about.
don't understand anything. Okay, that is fine. So P inverse for a 2x2 matrix, the finding the inverse is very easy, right? So what is the inverse of this matrix? What you do is nothing but you exchange these two entries and you put a minus sign here. In these two entries you will put a minus sign, but then determine like divide the whole by its determinant. So determinant is what? Here the determinant is coming out to be 2 minus 5, that is equal to minus 3. So it will be minus 2/3, minus minus will be plus, it will be plus, and it will be minus 1/3. This is the P inverse. Everyone got it? Minus 2/3, 5/3, 1/3 and minus 1/3. This is the inverse. Now look here. I want you guys to find out P inverse AP. This is nothing, three matrices you have been given. P inverse is minus 2/3. You just have to multiply. I am going step by step so that it is easy for your understanding. At last I will explain the like whole crux of it. Yeah. So calculate this. Tell me what it is coming out to be. Quickly. Are you guys solving?
Screen left, madam. Screen is not visible.
Okay, wait a second. Now it is visible, right?
Yeah.
Okay. So here, what? Tell me what are you getting?
One zero zero four.
1004. Yeah, that is right. Others got it? See, guys, this is basic. It's like 2 cross 2 matrices you have been given and you have to multiply them. At least this you should be able to do quickly in 2 to 3 minutes. So I will not do it whole, but the final answer you're getting is 10. It's just 2 steps. First you can multiply these two, then multiply with the third one. It's coming out to be 1004. This is nothing but a diagonal matrix, right? You all know what a diagonal matrix is. Only the diagonal entries are there, rest are 0. We call this diagonal matrix as D. And this whole process you did, it was known as diagonalization. So diagonalization is nothing but for a given matrix, if you have to diagonalize it, you will do nothing but find the eigenvectors. Then from that eigenvectors, you will form a modal matrix, which I called as P. Then after that, you will find P inverse A into P, and that is definitely going to be a diagonal matrix. And this whole process was called as diagonalization. P inverse AP is equal to D. Now, you might be wondering, like, what is the fun of doing all this, right? Does anyone know what is the significance of diagonalization? Anyone?
Maybe to find the powers of a
Yeah.
matrix.
Yeah, that is correct. Anyone else who knows why is diagonalization important? See, diagonalization is important because it it helps you to find higher powers of the matrix A. Suppose you have the matrix A, it was simple, right? It was 2 cross 2 matrix, not a big deal. If I tell you to find A square, that will be pretty simple for you. You will multiply A with A and you will get A square. I'll tell you A cube, you will do again. But what if I ask you to find out A to the power 100 or A to the power 20? Even A to the power 20 for a 2 cross 2 matrix is going to be very lengthy, right? So diagonalization helps us in finding higher powers of the matrix. And how is that? See, we defined here that P inverse into A into P is D. After finding the modal matrix and its inverse for a given matrix A, we do the diagonalization and we find the diagonal matrix, which in this case was 1, 0, 0 and -4. After this, what we can do? We can pre-multiply on both sides with P. Pre-multiply with P. So that is P into P inverse A, P, and here it will be P into D. Correct? Now, this P inverse P will be I. So it will be A P is equal to P D. Now again, post multiply. Here it was pre-multiply. It is the sign of multiplication, not X. So post multiply with P inverse again. So from post multiplication, here it will be A into P inverse is going to be P into D into P inverse, right? Again, this P and P inverse will form what? I. So A is equal to P into D into P inverse, right? Now, for finding the square of this matrix, suppose you have to find A to the power 2, what you will do? You will multiply P D P inverse again with P D P inverse, right? Because this is A, now you will multiply A twice. P inverse P will be I, so it will be P D. D into D is D square P inverse. Again, repeat it for 3, A to the power 3. So it will be nothing but A square is this, and multiply it with A gives P into D into P inverse. Then multiplying with A square, it gives P D square P inverse. Again here P and P inverse will be what? Nothing but I, identity matrix. So it will be P, and this D multiplied with D square give D cube and P inverse. So it will go on like this, and you can generalize that A to the power n is nothing but P D to the power n and P inverse. Now see, this is useful because even if you have to find A to the power 1000, this P and P inverse is not going to change. You have found it earlier, you find P, you find P inverse, then D to the power 100 is simple. Why? Because it is a diagonal matrix. Each entry will just be raised to power 100. If I give in this question that find A to the power 100, that will be nothing but P, then D to the power 100, then P inverse, and here D to the power 100 will be nothing but 1 to the power 100 is 1, 0, 0, 4 to the power 100, which you can find easily. Then you can multiply these 2 cross 2 matrices and you will get the higher powers. So that is why this concept was important. So did you guys understand?
Then madam, this A per 100 can be diagonalizable. You can find another P matrix for that.
For the
Suppose
P, yeah, like for A power 100 also, I think the modal matrix should not change. That is why you are getting this now. P and P inverse remain unchanged. Yeah, there are two things which I need to tell you, that not every matrix is diagonalizable. See, 2 points are there. When you are finding the eigenvectors,
they should be distinct.
it should be distinct, correct? If there are not distinct eigenvectors, then the P matrix which you are getting, it will not be like, it will not be a square matrix, and you there will not be distinct eigenvectors, so you cannot find the P matrix. And that is why this process is only applicable if you have distinct eigenvectors, because there are some cases where the eigenvalues are same, and sometimes the eigenvalues are same and eigenvectors are different, but sometimes the eigenvalues are same and eigenvectors are also same. In that case, you cannot find the diagonalization matrix in this method. I think my screen is gone again. So all of you understood this concept, right? It's a very important concept, right? Like if you have to do this in your exams, like A to the power 5 or A to the power 10, something like that comes, this process will be helpful. That time you cannot use calculator or other stuff. Now see, I told you at the beginning that let's not focus on the question, let's focus on how the process of diagonalization is done. Now we can go back to question. What it was given is that compute P inverse AP and then A to the power n if A is this and P is this. They had already given you the P matrix, and simply what you had to do was find the P inverse, then multiply P inverse A and P, and you could have gotten the A, like A to the power n. But if the P matrix is not given, I did this question is in this way so that you can understand how to calculate the P matrix. P matrix is nothing but the eigenvectors of this matrix. You find the distinct eigenvectors of this matrix and put it in this form. That will be the P matrix. So should we move forward, or you need to write something down? You need to note something down. All of you have noted this? Should we move forward? Guys, please respond. Should we move forward, or you need to
Yes,
copy
yes.
everything? Okay. So now if you have understood this question, let me take a break because this was lengthy. I want you guys to diagonalize one matrix. Diagonalize the matrix. Oh, wait. So this, sorry. Where did it go? Okay, whatever. So this is the question. Diagonalize the matrix. So the matrix is given as A equal to 3 0 0 minus 3 4 9 0 0 3. So before jumping to the solution, can you guys tell me how to do it quickly? Anyone? Please note this down because like, again my screen will be gone.
This finding eigenvalues.
Yeah, find the eigenvalues.
Then
Then first check if
matrix.
the
They are
eigenvalues are
distinct.
coming out to be same or different. If they are
Distinct.
different, there will be distinct eigenvectors. If they are same, then also find eigenvectors, because for same eigenvalues there might be different eigenvectors or there might not be different eigenvectors. So you have to find eigenvectors. If all the three eigenvectors are distinct, then proceed to what?
Find
Proceed to
P
finding
model
the
matrix.
model matrix and diagonalize it. So I want you to solve this and then find, okay, find A to the power 10 only if it is diagonalizable. If it is diagonalizable. So quickly, because we do not have a lot of time, we have 15 minutes, and we will do, after this we will do one last question on Cayley-Hamilton theorem, a simple question, and we will wind up the session. What are the
From
eigenvalues? Huh.
eigenvalues are 4, 3, 3.
Yeah, eigenvalues are 4, 3, 3. So here you can see that the algebraic multiplicity of
On screen, not visible.
eigenvalue. Oh, it's not visible.
Yes.
Wait a second. Now is it visible?
Yes, ma'am.
Okay, so see here, we have lambda equal to 4, 3, 3. Like we got 3 eigenvalue, and corresponding to lambda equal to 3, the algebraic multiplicity is 2. Like we have got 2 values of lambda equal to 3. Now, did you attempt to find the eigenvectors? Did anyone find?
For lambda equal to 4, eigenvector is 0, 1, 0.
For lambda equal to 4, yeah, the eigenvector is going to be 0, 1, 0. It's right. Huh. And for lambda equal to 3, for lambda equal to 3, what are the eigenvectors we are getting? Are they same? Are they different? Tell me.
Different.
They are coming out to be different. Yes. What are they?
0, 0, 1 and 1, 0, 0. Minus 1, 0, 0.
Um,
Actually, one after making a minus 4I equal to 0,
uh-huh.
only one equation you get a valid one. First and third row becomes 0.
Then 3x1 minus x2 minus 9
For
x3 will
lambda
be,
equal to 3,
yeah.
Uh-huh. You will
first
be
row and third
getting
row
one
elements
equation.
entries all are 0.
Yeah.
Then one equation will be,
Then the third equation is also going to be 0. There will be only one equation. So
yes.
from one
Yes.
equation, you know that you will find one unknown, and rest two को आप find in terms of that. Okay, let me show you how to do it. When finding for lambda equal to 3, our matrix is 0, 0, 0, minus 3, 1, 9, 0, 0, 0. So all of you are reached till there, right?
Yes, yes.
Yeah, then alpha 1, alpha 2, alpha 3 equal to 0. From first row, you get to know 0 times alpha 1 plus 0 times alpha 2 plus 0 times alpha 3 is equal to 0. Again, from third row, you will infer the same. But from second row, minus 3 alpha 1 plus alpha 2 plus 9 alpha 3 is equal to 0. From here, you can express alpha 1 equal to take this minus 3 alpha 1 here on the right side. It will be 3 alpha 1 is equal to alpha 2 plus 9 alpha 3. Right? Then alpha 1 is going to be alpha 2 plus 9 alpha 3 divided by 3. Correct? So, here what you can do is that you can choose alpha 2 to be K2 and alpha 3 to be K3, because only one equation is there now. You can find only one unknown that you found out, alpha 1. Now alpha 2 and alpha 3 you can choose, so choose them as K2 and K3. Then what is the vector v going to be? Vector v is going to be alpha 1, right? Then alpha 2, then alpha 3, which is going to be what is alpha 1? Now I have taken alpha 2 as K2, so it is K2 plus 9 K3 divided by 3, right? Then alpha 2 is K2 and then alpha 3 is K3. Understood? Is it clear? Now here what you can do is you can break it into two distinct eigenvectors. Sometimes you're not able, sometimes you will get the same, like even if you break it into two vectors, you will get same vectors, but in this case you're going to get different vectors. How is that? See, you can break it in any way. So how I do it is that here it is k3, so I'll put k3 here and here it should be 0. One you have to make all k2, one you have to make all k3. Now here k2 is there, so I'll put 0 here and k2 here. And what will be this? K3 by 9, k3 by 3, that will be 3k3, and it will be what? K2 by 3. Correct? So this whole is on k3. Adding these two, we will get this again, na? That is why I broke them. So it will be v is equal to, taking k3 out, this will be 300. No, sorry, not 300. It will be 301. 301, and here we will take k2 out, and it will be 1 by 3, 1 and 0. So these are the two distinct eigenvectors we are getting here. Understood? Now you can put the values of k2 and k3 according to you, whatever like you like. After that, you have to find P matrix. Now here we know that there are three distinct eigenvectors we are getting. Three distinct eigenvectors. Now please find the matrix P quickly and P inverse also. Here what I can do, यहाँ पे मैं K2 की value I will put as 3. Put K2 as 3. Again I am doing this for making this fraction equal to 1. It will be 1, 1 and 0. Sorry, 1, 3, 0. So the P matrix will be what? What was the first eigenvector? 3, 0, 1. 1, 3, 0. Because like you can write it in any order. I am writing for the both the threes. I am writing first, then I will write for the fourth one, which got 0, 1, 0. So 0, 1, 0. Understood how we get this P matrix?
Yes.
Model matrix again. Now P inverse you can find on your own, and right now it's going to take time, so I will quickly write it down. It is coming out to be 0, 0, minus 1, then 1, 0, minus 3, minus 3, 1 and 9. So how you find D? D is nothing but what? P inverse?
KP.
P inverse AP.
P inverse A. Or is it the other way? No, this is the way, huh? P inverse PAP. So from here you will get D equal to what? Check it on your own end, but I am writing it down. And in next session, tell me what you are getting the value of a to the power 10. Okay. This is a homework question for you.
Okay.
In the next session, you tell me what you are getting. So now we will do just one last question. Okay. So bear with me for 5 to 10 minutes more. Yeah. Can anyone tell what this theorem states?
Every square matrix satisfies its own characteristic equation.
Yeah, correct. Every square matrix satisfies its own characteristic equation. So what does that mean? that if we have a matrix given and we write its characteristic equation, suppose something like there is a matrix whose characteristic equation is going to be say a matrix A, and we have the characteristic equation as lambda square minus 3 lambda plus 5. It's just a like vague example. This is the characteristic equation we are getting. This theorem states that if we put a matrix in it, it satisfies it. Like the square, if it is a square matrix, otherwise it won't satisfy. So a square minus 3a plus 5i is equal to 0 matrix. This is what this theorem states. So now a question based on it. Let's do one question based on it. Suppose we have a matrix given as 2 cross 2 matrix 3 minus 2 and 3. It is a square matrix. Now, which of the following statements follow from Cayley-Hamilton theorem? Okay, so first is A and A square have same eigen values. Second is A has two distinct real eigen values. Third is every vector in R square is an eigen vector of A. And fourth is none of these choices. So look at the question. There is a matrix given, and then there are certain statements like A and A square have same eigenvalues. A has two distinct eigenvalues. Every vector in R square is an eigenvector of A, or none of these choices is something we can infer from the Cayley-Hamilton theorem. So according to you, what are the correct statements? First, we will find the characteristic of equation. So here the characteristic equation will be 3 minus lambda square minus 4 equal to 0, which is coming out to be lambda square minus 6 lambda and plus 5 equal to 0, right?
Yes.
Yeah. So what will be the, from Cayley-Hamilton theorem, this matrix satisfies what? This equation. So we will write A square minus 6a plus 5i is equal to 0 matrix. So A square is what? Equal to 6a minus 5i. Now look at the first statement. It is telling A and A square have the same eigenvalues. So we have to check if this statement is correct or not. For A, what is the eigenvalue? Say let it is lambda, right? Say lambda is an eigenvalue of, let me write it more clearly. Okay. So lambda is an eigenvalue of A. Say. What does that mean? If A has an eigenvalue lambda, it means that A lambda is equal to lambda times V, lambda times some vector. This is what the definition of eigenvalues is. Now, for A square into V, we are checking that is it coming out to be same or not. It is going to be what? 6a minus 5i into V, which is equal to 6 instead of A, we can put, yeah, it's AV minus 5IV or 5B, we can simply say. Here we can put, it's not A lambda, it's AV. So 6AV, instead of AV, we can put lambda V. And instead of this IV, like we can simply write 5V. And here A square into V is coming out to be 6 lambda minus 5 into V. So you can clearly see that in this equation, lambda is the eigen value for A. But for A square, 6 lambda minus 5 is the eigen value. So this statement is not correct. We cannot conclude this statement from the Cayley-Hamilton theorem. Right? Understood?
Yes.
Yeah. So going to the next question, A has like next statement. A has two distinct real eigenvalues.
Yes, 1 and 5, so distinct.
Huh?
A's eigenvalues are 1 and 5.
Yeah, they are distinct.
Distinct.
But do we infer that from Cayley-Hamilton theorem? No. We don't infer that from this theorem. So this statement is not correct in context of the question. Otherwise, it is correct. Now, every vector in R square is an eigenvector of A. What about this? For the third statement, as you already said, we are getting lambda as 1 and 5. It means there are, from these two distinct eigenvalues, we will be getting two distinct eigenvectors, right? V1 and V2. And they will span in R square. है ना? And other eigenvectors of this vector will be linearly dependent on them. मतलब these two are the only independent eigenvectors for this matrix A. Other eigenvectors which we are getting from, we will be getting from these two only. So from these two, like from 1 and 5, we are getting two vectors, and from these two vectors only that it will be spanned, right? Every vector in R square is an eigenvector of A. It is not necessarily true, because only those vectors which are linearly dependent on V1 and V2, they will be the eigenvectors of A. Understood? You're getting my point?
Yes, yes.
Only those vectors which are linearly dependent on V1 and V2, they will be the eigenvectors of A. Not every vector in R square, because in R square there might be other vectors which do not satisfy this condition, so they will not be the eigenvectors of A. So the third statement is also not correct. This does not form. So ultimately we have none of these choices. That is the correct option. So do you have any doubt in this question? Or do I need to repeat anything? Otherwise we can end the session. You can provide me any feedback, whether I am going too slow or too fast, or maybe you need some different types of problems. You can tell me at the end of the session, so that in next session, because I want this session to be beneficial for you only. So what I find important, like that you should be knowing this, how to do this, I get those questions only. So if you have any suggestions, any feedbacks, you can tell me. Otherwise, we will end the session. So nothing?
No, ma'am, it's beneficial only.
Okay.
Okay.
Fine.
Any doubts are there? Next session we'll ask. Doubts are there, no? Next session we'll ask. Next session will be there, no?
Yeah, but do one thing, because see, I have to look for the doubts as well. You can put them right now in the chat box, so that I can take a note of them.
That what I told you, that next session is orthogonal complement. That
Orthogonal complement. I'm not sure about what you are exactly telling, because I have never heard about something like orthogonal complement. That's why I want you to like give me a detailed question or what your doubt is, so that I can
Orthogonal perpendicular Give perpendicular, orthogonal, perpendicular.
Yeah,
The terms instead
orthogonal.
of complement, the perpendicular that term also
It
use.
comes in inner spaces, ma'am. Related to inner spaces,
Inner
no?
product
Okay,
space.
Inner
it's
products.
so
It's
you
related to that.
okay. You want me to explain that whole process?
Now that just like what you're explaining now. One question. If you bring in the next class, you will good the concept.
Okay, the concept you want me to bring a question on that concept,
Yes,
orthogonal
yes.
complement.
Yeah.
Okay, okay. I'll try to figure it out what you are exactly asking. Uh, can you give me the reference of which lecture, in which lecture you had
This
studied that?
week three, it's there.
Week 3 lecture,
Yeah.
which lecture number? Week 3 has
Uh,
5 lectures, no? If
yes,
you can
yes.
provide me the lecture number so that I can go through the lectures, because I do not watch the lectures. However, I study the topics and prepare my own questions. So please give me the reference so that I can watch that lecture and then I'll explain to you.
It's in one only, ma'am.
Okay,
Yeah.
week 3 lecture number 1.
One, yeah.
Okay, okay, I'll do that. Okay, so see you all in the next session.